This is R.D. Sharma solution, class 12th, chapter 9. Continuity exercise is 9.1. What is continuity first? Now this is a road. You're walking, you're riding, or you're driving. The road is straight. You have no problem. You reach your destination. So this road is a continuous road. So the continuity is there because you are reaching from A point to B without any stoppage or breakage. So for any function, for every x there will be y. So every function will have some shape. You can call it as a road. So there can be multiple shape of various functions in mathematics. So what is discontinuity then? You are going, you have to reach destination B, but there is a breakage. Say, there is a breakage of the road, or there is a bridge which has fallen down. So that part is discontinuity. So continuity and discontinuity, how to know about that? For that, in order to check the continuity or the discontinuity, for that you need to know limits. Limits is the precursor or the background knowledge you must possess in order to actually show whether the function is continuous or discontinuous, right? So continuity and discontinuity is always at certain point, like you see at this bridge. For example, x equals 3, x equals 2, x equals 1. In this case, in this question, it is x equals 0. So you'll be told, please check the continuity at x equals this. For example, x equals 3. The question is been asked. So at this point, how to check? Just move a bit, just a bit, very small. Just move, walk on the opposite direction and front direction, just a little bit, and that we call as h. That h is so small that it can be, it is tending to 0. It is not 0, but it is 0. It is not actually 0, but very, very small distance you have traveled in either direction, and you see, whether it is broken or not. So when you move on the side which you are coming, that is called the left hand side, that is called the left hand limit, and on the right hand side it is called the right hand limit. So you'll add 3 plus h on the right hand side and 3 minus h, because h distance you have traveled on either side. So 3 minus h, 3 plus h, this is called as the left hand limit and the right hand limit. Left hand limit and right hand limit, if they are equal, so you have to go a step ahead. For example, this function. If I try to find out the left hand limit and the right hand limit, for example, x equals 3 we have to check, or x equals to 0 we have to check. Now you have to put that x equals 0 or x equals to 3 in that function. Now that value, if it is equal to left hand limit and right hand limit, that is, left hand limit has to be equal to right hand limit, and that value which is left hand limit and right hand limit has to be equal to the value of the function at that particular point. For example, 8, 8, 8 is coming. For example, LHL, RHL are 8, but the actual value at this function on this x equals 3 is 9. You'll say, no, it is not continuous, it is just discontinuous. So the LHL, RHL has to be equal, and the value of that function at x equals to 3 or any x equals k, where you are checking the continuity, has to be equal. Now let us come to this question. So we have to check the continuity of the function at fx at the origin. Origin means x equals 0, y equals 0. So this given, we observe this limit h tends to 0. This all you have to write, because you are actually presenting it to your examiner or your teacher. So this is the way you have to write. I am going to tell you the logic, the concept behind solution of these questions. Okay. So the question, the background I am going to tell you, but all these you have to write by yourself. Now, continuity we have to check. So the first thing which I told you was the left hand limit and the right hand limit we have to find out. And what is left hand limit? Because its origin x is equal to 0. So when x is equal to 0, what do? We just go on the left hand side a very tiny bit, that is h. We just go a distance ahead of 0. So 0 minus h and 0 plus h. So x will be equal to 0 minus h in the left hand limit case, and the otherwise case right hand one we have 0 plus h. So in place of now see here, x has changed its value. It is not 0 now, because when you are subtracting h or adding h, it is not 0. So there are two things given in the function. When x is not equal to 0, when x is equal to 0. So we are going to take x is not equal to 0. Okay, x is not equal to 0, that we are going to take, or that we are going to use. So here, this we have to use. So x divided by modulus x. Here also x divided by modulus x we are going to use. What is modulus, or the absolute value of x? Whatever value you put in here, negative or positive, this absolute or modulus will always give you the positive number. Always you will get the positive number. Okay? So negative to positive, positive to positive. Okay. So x is 0 minus h, put it here, x 0 minus h. Here also 0 minus h. So I hope these all you are going to write by yourself. This is the way you have to actually write. Here on the right hand side, what we are going to do, 0 plus h and 0 plus h here. What is 0 minus h? It is negative h. 0 minus h is negative h, but the modulus or the absolute value will be positive. So it will be h here in the denominator. Here we have h, denominator 0 plus h, h will be h only. Cancel it out, it is negative 1. Cancel it out, it will be plus 1. So what do you see? The left hand limit and the right hand limit, they are not same. They have different value. One is negative 1, one is positive 1. So the first test has failed. The first thing for continuity or discontinuity is left hand limit has to be equal to right hand limit, which is not coming here. That is why this is a discontinuous function at the origin at x equals 0. Maybe at x equals 3, x equals 9, x equals to negative 5, it may happen this function is continuous. But at x equals to 0, it is discontinuous. I am just giving a fake idea. For example, left hand limit, right hand limit both are 1. And the value of this function at x equals 0, it is already given in here, 1. So if this case is there, left hand limit, right hand limit are equal, and the function value at x equals 0 is also 1, then it is a continuous function. But right now it is discontinuous. It is not continuous. It is discontinuous. A function fx is defined as, I told you there is a x equals 3, we have to find out this is a road, this is a pathway, and at x equals to 3 you have to find out whether this function is continuous or not. At x equals 3 it is given proper value 5, but we will have to check it just behind 3 and just forward, just a bit forward 3. Okay, so how you are going to write? This way. This is the actual way you are going to solve your question. Left hand limit, right hand limit, all these you have to write by yourself, because this is the way you actually answer the question. But as far as I am concerned, I am going to tell you the logic here. So I am going to write the left hand limit, right hand limit, And since x equals 3, we have to check. And since we are taking the left hand limit, we just subtract a very tiny number, very tiny number, which is actually equal to 0, but not 0. I hope you got the idea. So x equals 3 plus h on the right hand limit. And when 3 plus h, 3 minus h, they are not equal to 3. So we have to check, we have to use this function in order to put this x value. So x square minus x minus 6, x minus 3, this is the function you are going to use. So 3 minus h whole square minus 3 minus h minus 6 divided by x is 3 minus h minus 3. And what you are going to write here? You are going to put x equals 3 plus h. So 3 plus h whole square minus 3 plus h minus 6 divided by 3 plus h minus 3. Okay. So let us open this. This is 9 plus h square plus minus 6h. Here you are going to get negative 3 plus h minus 6 divided by 3 minus h minus 3. 3 gets cancelled. You will get negative h. Here you will get 3 is 9 plus h square plus 6h minus 3 minus h minus 6 divided by 3 gets cancelled. You get h here. Okay. So you can cancel these 3, 6 because it is negative 9. 9 gets cancelled. Here also 3 and 6 and 9 gets cancelled. So what do you get? H square, h minus 6h is minus 5h. So h square minus 5h divided by minus h. Here you have h square plus 5h divided by h. Now take h common here. H minus 5 by negative h. Here you have h plus 5 by h. You can cancel this h. You can cancel this h. You have h minus 5. So negative goes up. So just change the sign and write it again by 5 minus h. Here you have 5 plus h. Now limit h tends to 0. We'll apply it here. This is going to be 5. This is going to be 5 again. So the left hand limit and right hand limit, they are same. They both are 5. That means left hand limit and right hand limit are equal. But there is one more check we have to do. One more level we have to go. That is, at x equals 3, what is the value of this fx? And it is already given in the question that fx at x equals 3, the function f3 is already giving the value as 5. So I told you the limit should exist left and right, left and right, and the value of these limits should be equal to the value at x equals 3 of that function, which is in this case equal to 5. So we can safely say that this function is continuous at x equals 3. A function fx is defined as this. We have to check it at x equals 3. Okay. So x equals 3 we have to check. And what is the value of this function at x equals 3? It is already given. It is 6. At x equals 3, fx is 6. So we will now try to find out the left hand limit and the right hand limit and try to find out whether these two values are equal or not. Okay. So let us see here the left hand limit and right hand limit. The left hand limit, right hand limit, they are equal, and if they are equal to 6, because the value of the function at x equals 3 is also 6, then we'll say it is continuous. Otherwise, we will declare that this function is discontinuous. So let us see the left hand side, LHL, and right hand limit. So what you have to do at point x equals to 3, you have to check. So just put x equals 3 minus h on the left hand side. Because h is very small number. It is not 0, but it is equal to 0. X equals 3 plus h. So what function you have to use when it is not x is not equal to 3? X square minus 9 divided by x minus 3. I am putting x as 3 minus h. Here I am putting in the place of x 3 plus h. So you get this as, see, 3 minus h whole square is 9 square plus h square minus 6h minus 9 divided by 3 minus h minus 3, 3 gets cancelled, you get a negative h here. Here also you 9 plus h square plus 6h minus 9 divided by 3 gets cancelled, you get a h here. So 9 gets cancelled, here also 9 get cancelled, h common, so h minus 6 divided by negative h plus 6 divided by h gets cancelled, minus goes up, so it is 6 minus h, here also 6 plus h, so h is tending to 0, so this left hand limit is 6, right hand limit is also 6, and since we started with what is the value of function at x equals to 3 for this function, so left hand limit, right hand limit exists, it is equal to 6, and the value of the function is also equal to 6, because that is the next step, but we have already done it. f3 is 6, limits also exist, and that is also equal to 6. That means there is no breakage in the road, and you can draw that function without lifting your pen, right? So actual solution I am showing you right now, and this is how you are going to write. Not what I am writing. I am just giving you all the ideas so that you are aware what exactly is going on. But this is the way you have to write. Given, we observe, LHL, write LHL given, then fx is continuous at x equals 3 with all the computation which you see here. So I hope you got the idea how we are going to find out the continuity and discontinuity. We'll take this one in the next discussion. Till then, thank you so much. Take care of yourself.